Hi, in today's video I would like to introduce you a very nice problem of Moroccan exam 2017. Here is the following setup. We have x and y as a positive integers. We have a p as a prime is superior or equal to 5. We have the following equation. P is multiplied by x plus y to the p minus 1 equals 2017. Okay, 2017 is a prime. Our goal, we are going to solve this equation, okay, to find x and y as the solutions of this equation. Okay, so I'm going to remind you with a very important and useful tool. It's called little theorem. When we have a p as a prime is not dividing n as an integer, implies n to the p minus 1 is a congruent to 1 mod p. Okay, before we proceed with the solutions, we are going to show these facts. We are going to prove p is strictly inferior than 2017. The second fact, we are going to show p as a prime is not dividing y. Okay, so the last fact, we are going to show p as a prime equals 7. Okay, then we proceed with the solutions of this equation. Okay, so go ahead, pause this video if you would like to give it a try to this problem. When you are, come back to see the full solution. Okay, let's get into the solution now. So notice here 2017 as a prime equals 2 to the 5 is multiplied by 3 to the 2 is multiplied by 7 plus number 1. Okay, so 2, 3 and 7 are the primes. In order to show the first fact, p is strictly inferior than 2017, we have this equation: x equals 2017 minus y to the p minus 1. Okay, we have x and y as a positive integers. That means 1 is inferior or equal to x. Okay, I'm going to multiply p by both sides. I will get p is inferior or equal to px. Okay, I'm going to replace px with its value. I get 2017 minus y to the p minus 1. So as we know, y is a positive integer. That means y is strictly superior than 0, and also p minus 1 is strictly superior than 0. Okay, notice here this value p to the p minus 1 is always strictly inferior than 2017, because we have the sum of these two terms equal to 2017. That means this one is strictly inferior than 2017, since we have p is multiplied by x as a positive number, because you have x is a positive integer and p is a positive as well. So that means this one is strictly inferior than 2017. This one implies p is strictly inferior than 2017. So we are proving this one. Let's move on to the next proof. We are going to prove p is not dividing y. Okay, in order to prove this one, we are going to assume p divides y. Okay, we know two things here. P is dividing, p is multiplied by x. Okay, and also since we have p divides y, that means p also divides y to the p minus 1. Okay, this one is telling us p divides px plus y to the p minus 1. Okay, so this one equals 2017. That means p divide 2017. The only way to get p divides 2017, p must equals 2017 or p equals to 1. P equals 2017 is impossible because we already proved p is strictly inferior than 2017. That means p must equals to 1, which is impossible, because p as a prime is always superior or equal to 2. That means it's a contradiction. That means p not divide y. Okay, now we have proven this second fact. Let's move on to prove p equal to 7. Okay, since p not divides y, p as a prime and y is as an integer, according to the little theorem, this one implies y to the p minus 1 is a congruent to 1 mod p. Okay, furthermore, we have p is multiplied by x is a congruent to 0 mod p. Okay, because p is dividing px. Okay, then I'm going to add this one and this one. Get y to the p minus 1 plus p to the x is congruent to 1 mod p. Okay, I'm going to replace this one with 2017. I will get 2017 is congruent to 1 mod p. Okay, by taking number 1 to the left hand side of this equation, I will get 2016 is congruent to 0 mod p. Okay, this one implies p divides 2016. Let's take this important thing at the top and continue with our problem. In the last board, we were working on the divisibility statement and came up with this result. We found p divides 2017. By using this fact, we have p divides 2016, and 2016 equals 2 to the 5 is multiplied by 3 to the 2 is multiplied by 7. Okay, since p divides these numbers, we have three possibilities. Okay, p equals 2, or p equals 3, or p equals 7. Okay, since p is superior or equal to 5, as the earlier condition here implies p equals 7. Okay, we have proven this fact. In order to take p equal to 7, verify this equation, I'm going to go through this condition. Here is x and y as an integer numbers and as a positive numbers, implies this condition is valid only if p equals 7, if only we have there exists x and y as a positive integers. Okay, verifying this equation, p is multiplied by x plus y to the p minus 1 equals 2017. But if p is not equal to 7 for all x, y as an positive integers, implies p is multiplied by x plus y to the p minus 1 is not equal to 2017, because this is a specific value. Okay, to verify this equation. Okay, now we are going to solve this equation based on this condition, p equal to 7. So that means p equal to 7, we have p, I'm going to replace p with its value. I'm going to replace p with its value, 7x plus y to the 6 equals 2017. Okay, if you take a look carefully, this one equals 7 is multiplied by 2 to the 5 is multiplied by 3 to the 2. Okay, plus 1 to the 6. Okay, this expression is the same as this one. We have the 7 here, we have the value of x here, we have y equals to 1, we have 6. As this expression is telling us the value of x is this value and the value of y is this value, y, 1. So the solution of this equation, if you calculate this term, 2 to the 5 is multiplied by 3 to the 2, you find 288, and the value of y equals to 1. This is the first solution. I'm going to find the other solutions. If you take a look at this equation, we have y to the 6 equals 2017 minus 7x. Since we know 7x is strictly superior than 0, okay, because we have x as a positive integer, that means this one is strictly inferior than 2017. So that means y is strictly inferior than 6th root of 2017. If you calculate this one, you will find almost 3.15. Okay, since y is an integer, that means y it will take following numbers, take 1, 2 and 3 for all y strictly superior than 0 as a positive integer. Okay, we already found y equal to 1, which is the solution, first solution. Let's check the second and third solution. If we have y equals 2, you will find 7x equals 2017 minus 272. You'll find 272 as a solution, and y equals 2. Okay, if y equals 3, this one is telling us I'm going to replace y. We'll have 7x equals 2017 minus y to the 6. This one, after replacing this one, we will find x equals 184 and y equals 3. And the first solution was 288, x equals 288 and y equals 1. Okay, so here is the following solution that I found. So I have done with this problem. If you are interested in watching this one, don't forget to support us with your like and subscribe. Thank you for watching. I will see you in the next video. Bye.